Hey guys.
Hello.
So this week we got some stuff
Yes.
in the mail here.
Quite a bit, actually.
We are getting ready to take a rather epic tour of the country.
Yep.
It's the high point of which is going to be stopping at Parallax headquarters in Rockland, California for
Yep.
their expo this April. We're going to be doing a lot of other things too while we're driving across the country. A lot of which is going to involve making some content for you guys from the road.
Yes.
We'll be recording first spins and zombie techs and lots of Toymaker television in the field video stuff.
Yes.
So I don't know. That should be a really good time. We're taking one of our longtime friends of the show, Peter, is going to be driving with us on the way out, and yeah, he's a bit of a hacker too. So we're probably going to get in trouble along the way. And what are you doing?
I'm just showing some of the stuff that we got.
Well, we'll get to there. I was just explaining to people what's going on so they know.
Yeah.
Yeah. Okay, so we're gonna have to be able to produce video from the road,
Right.
but we're not really set up to do that right now
Right.
because we just work in the studio here.
Right.
So if you could bring this over here. This is our power supply for the camera that you guys are normally looking through here. And it plugs into the wall. And it has this nifty little adapter that goes into the camera. So the camera thinks it's got a battery in it. That's what we normally use, and that was for the RoboJib. But we needed a way to go wireless with that. So you can take that. We needed a real battery. So we've got that one there. Now we need a way to charge our batteries in the car. So we got a charger that when you combine this little cable here
into cigarette lighter thing.
That connector on this battery charger, we can charge it in the car, or flip that out and we can charge it in the hotel room too.
Huzzah.
Which will be nice and handy.
Yes.
Okay, so yeah, there's that, and then we needed to be able to
Replace that.
yeah, this is our 2 gigabyte SD card that we were using to shoot with this camera, and it's not nearly fast enough to shoot video.
It was a good card.
So we replaced it with a 32 gigabyte SanDisk Class 10 30 megabit per second HD video
Yep.
SDHC card.
Yep.
So that's what you guys are seeing now, and there's probably going to be a bit of a quality increase because I just doubled the amount of picture information we can store in our video while it's streaming to the disk.
I see.
Now, we'll be able to improve on this again once we get our HDMI streaming box.
Mm-hmm.
But for now, this is going to do, and it's going to let us take the camera mobile with us. We have batteries. We have the ability to shoot a lot more than the 8 minutes of video at a time that we could do before, and now we're shooting in a much higher quality.
Correcto.
All right. And I think that...
You forgot the SD
oh,
card reader.
yeah.
Little space capsule.
And that is so that we can get video on and off the card no matter where we are, no matter what computer we need to use to do it. There's going to be a whole lot of information coming up about the mobile rig that we're building. We're building it into a mobile rack case.
Yep.
It's going to have our multi-tracking recording studio capability and nonlinear video editing production all in one little rack case.
Yes.
And that's what we'll be taking on the trip with us. So, if you've been wanting to donate but looking for an excuse to donate to the show, now would be a great time because we're, having to put out a lot of money to facilitate this trip. And it's going to be really awesome, and we're going to get a ton of cool stuff for you guys.
Yep.
All right, let's see what we have to show you guys this week. I think we're going to be doing some hBridge updates.
Lovely.
And I think Addie has...
The first section of the xBee wireless kit tutorial.
Oh dear, Addie's going wireless.
Huzzah!
Okay, so here's some progress on the RoboJib. You guys saw the hBridge doing its thing last week, and now we have it hooked up to a parallax propeller, and that is doing pulse width modulation. We also have changed out the power supply for the actual one that's going to be used. A little bit, yeah, so a little switch mode power supply. And yeah, I've got it set up so it can ramp up speeds, ramp down speeds, and reverse. Addie, if you flip that on, we can see that.
Ooh. And did you like my
it's
Vanna
speeding
white?
up,
Yes.
slowing down, reversing. Now this isn't the final code. The final code will have the pulse width being much, much faster. So you won't hear all of the jitteriness. But you can see that all the functionality is there, and we've got pretty good control of where it turns around, where it stops, how fast it's going, all that sort of thing. Next major improvement here is to solder up a control board for it, for the hBridge, get it off the breadboard and on a real board, and solder up a propeller board for it from scratch.
It's like Wheel of Fortune.
Eddie's gonna get her finger caught in the sprocket.
Oh.
It's gonna be great.
Bankrupt! Oh.
Alright, let's see what else we got going on today.
Okay. So welcome to the first portion of the xBee wireless kit tutorial. Yes. So I've seen that there are a lot of xBee tutorials with the Arduino, and if you haven't already, go ahead and check the one from our good friend Jeremy Blum at SciGuy14. He's got a good one for the Arduino, but I haven't seen any for the Parallax, and the text PDF for it is
I think
like,
one of the things
what?
that why there wouldn't be yet is because this board is not for sale just yet. It will be soon though.
Well, it's on pre-order.
Yeah.
This is the Prop BOE.
So, yeah, I'm sure there will be official tutorials up for that soon. But for now, we have Addie to teach us how to do it. So
Correct.
that's dangerous.
That's not. It's harmless. So,
So what are these things and what do they do?
All right, this is the xBee wireless kit from Parallax, and what it has. So xBee is like, I like to think of them as Wi-Fi nodes. So if you have something here with an xBee and you have something here with an xBee, they can communicate to each other as if they had a serial cable in between them, which is really cool. So this wireless kit comes with a couple of things. It comes with, okay, so these two are the antenna modules, and there's like, I want to say 12 to 16 channels, like in the gigahertz range that they talk to, so kind of like ham radio, but with xBees instead. And then this, let me just put that down. This is the USB adapter, and so using a USB-A to mini-B connector, you can just hook it to your computer, and this is where you can configure these.
And that's the same kind of cable you would use to program your propeller or other microcontroller these days.
Right, exactly. So when you hook it up, it gives enough power to this, and then you can do whatever you need to do with it. Usually the USB is used to configure it, to quasi-program it, and to put any settings. So, and we'll go into that more later. And this adapter is a microcontroller adapter, and so this is one that you can plug into, say, your breadboard section of your microcontroller. In this case, we're using a prop. But the cool thing about the Prop BOE is that if you notice here on the bottom, there are actually xBee holes. So you could take one of these. Headers, yes. And you can just put it in there. No problem.
So the Prop BOE has a dedicated headers just for xBees.
Well, that'd be the efficient way of saying it, yes.
Yeah.
So I wanted to first then show, oh, and I had to explain something too. So the reason why you actually need an adapter rather than just plugging the xBee into the breadboard is because the xBees have something like a 2mm hole pin system. It's like not normal for the board. So if you notice, can you see this okay?
Oh, so they're not on
They're not
1mm centers.
Right. So that's why if you have one of these adapter boards, and I'll just pretend to put one in here for now. It just snaps in really easily. And then there are these awesome headers that they provide.
Now those are standard headers, those.
Right. These can fit into the breadboards.
Mm.
So all you have to do, and I guess I shouldn't have done that, but you can just take these, put them into the holes, and then solder them from up here. Oops, that's actually a part on the board. I was trying to wipe it off. But you can just solder them, and then it'll be easy to just stick into the breadboard, and et cetera, et cetera. I have not done that because I have not needed to. I've been using just the USB one, and then this one I've just used on the xBee headers here on the Prop BOE. So, most of the tutorial that I'm going to be doing in just a little bit is using the xBee. So I guess I'll hook this up. The xBee on... Wow!
You're just all over the map today.
But they're small. Okay. All right. xBee on the USB adapter, and pretend this is plugged into a computer.
And just remember, folks, if you need heart surgery,
I am
Eddie's
not
going to
the
be the
one.
one taking care of you.
That's horrible. Okay. And we're setting up a feedback loop mechanism where when this sends something to this xBee, it's going to go from the data, I believe it's data in, straight to the data out. And so all you have to do is connect to the two pins that are data in, data out. And so that way when this talks to this, it immediately returns it back to
So
this.
in this case, you're putting the xBee onto the Prop BOE as just a power source and a convenient way to tie its data in pin to its data out pin.
Correct.
And we can give you guys a close-up view of the little hack that I came up with to allow her to do this.
Ta-da!
Okay, so you can see this is just a tiny little bit of resistor lead
Yep.
from another project, and we bent it into a U shape, and we're just going to put this into the DI and DO headers slots on the Prop BOE. And let me get focused on that for you guys. You can see it there.
Yeah.
Addie put it right in those pins there, and she can still put her xBee in there because its pins are able to fit in there with that little jumper in place, and that turns her Prop BOE into a
xBee talking machine.
yeah, into an echo server essentially.
Yep.
So anything that she sends out with this unit here
goes here and then bounces right back. It's like, I'm rubber, you're glue. Whatever you say goes back. Wait. Yes, whatever you say goes back to you. Except for the nice stuff.
I see.
Yes.
Okay. And I think that pretty much covers the introduction to xBees.
Yep.
Next time we get to these,
I'm gonna actually show some the start of how to download the software and get to work and get to doing some test querying and sending of things.
all right.
Yep.
Okay, so since a lot of this is just programming, I wanted to show you guys, kind of take you step by step through how to actually get the software and all that. So I just have a simple Firefox window up here. I've searched for xBee X-CTU software, and it's done by, I think, the folks who make the xBees. So I searched, and it's actually, nope, okay. I think it's the first link, which makes sense. So here we go. Digi has their website, and it's actually down here, the XCTU 32-bit version, blah, blah, blah. So you install it, and here's that window. But I've already installed it, so we don't need to. And ta-da! We have XCTU right here. So I'm going to double click and open that. And so there's a couple things that we got to do first. First, so if you've got everything set up like how I showed you earlier on the bench, we have one xBee that's connected to the computer through USB, and it's on the USB adapter. And then we have the other one that's connected to the prop BOE, which is obviously turned on, and we just have a wall wart going to power this board.
And we've looped the pins together, as Addie explained before.
Right, so it's a
dead
feedback.
In, dead out.
Yep, feedback tester, so to speak. And so the first thing we want to check is to make sure it actually works. And so we have here the COM port setup, and you don't actually have to do anything here necessarily. But I've clicked on the COM7, the USB serial port, and what I'm going to do is I'm going to test and query. So it's kind of like pinging to make sure that the computer can actually talk to this xBee. And what you see is that the communication with the modem is okay. It gives us the modem type, the modem firmware version, and its serial number. Now, currently it's at a baud rate of 9600, which is it's a default, but say I change this to 2400. Now, unless you've actually put or set up the firmware so that it can talk in 2400, it shouldn't work. So what I'm going to do is I just changed it to 2400. We're going to test query it again. And what you see is oh, okay, there we go. Action required. Unable to communicate with modem, verify COM port selection, blah, blah, blah. So obviously it doesn't work. So this is the error version. So unable to communicate with modem, fine. All right, so we're going to go back to 9600, test query to make sure that's all good and dandy, and it is good and dandy. All right, and if we go to terminal and we type something simple like hello world, you'll see that what we type is in blue, H, and what we get back is in red. So we'll see that it's actually really fast. The packetization speed of this thing is such that even before I type the next letter, it's already gotten something back. And you can actually type like whole packets by clicking on assemble packet. So I'm going to clear the screen. I'm going to say assemble packet, and we're going to send hello world again. And then when we send the data, what you see is that my packet is hello world, and I get back hello world. So it's working. Lovely. All right, so I'm going to go ahead and close that. And another thing to note is also that you can run range tests, which tell you how good your signal is, so to speak. And it goes from negative 40 decibels to negative 100 decibels. And the better it is, the less negative. So that would be -40 is better than -100. So I just clicked this RSSI signal strength. It's got this neat color bar that indicates the -40 to -100. Here's the range test, which shows you at what percentage the signal is. And we're going to go ahead and we're going to start. Okay, so we see that we're at 100% and that this color bar has reached up to -40, which is awesome. And it'll keep sending this range test and it'll keep pinging so that you can see of all the pings how many actually work. Now usually you'll be able to see what you've transmitted. So if you look at the transmit, we see that this little line has been transmitted. But what you can see is that we don't have it here, and usually I think on most people they're actually able to see this. So and then if I put my hand above the xBee, theoretically, we should see a decrease, just like you did. So you see that there's a slight decrease in the signal strength. Okay, and those are the basic tests. We'll continue on next week.
All right, thanks for explaining all that to us, Addie.
You bet.
Let's see, what else do we have that we wanted to talk about today? Oh yeah, a good friend of the show, Jason, over at tautic.com.
TAUTIC.
Yeah.
Yeah.
Well, he was watching the live stream and we were hacking on the hBridge, and he noticed that I was using a breadboard that didn't fit the power supply that he'd sent over before.
Right. Which is awesome, by the way, if you guys haven't already gotten
so I needed one of these more standard boards, and he just sort of volunteered, because he sells them in his store, the boards that fit these perfectly. Mm-hmm. It's got 5 volts on that rail and 3.3 on that rail.
Which is super handy.
Yeah, and he of course sells the breadboards that match for really cheap, but you know, we're toy makers, so cheap is too expensive. Y'all don't donate enough. But fortunately, guys like Jason are happy to send us
a crap ton of breadboards.
Thank you, Jason.
They're like golden nuggets.
Yes, and
but they're white.
We use a lot of these. I mean, you guys see these on the show almost every week.
Yep.
So obviously these will get a lot of use here. So thank you, Jason.
Thank you, Jason.
These will get a lot of use, and you guys should go check out Jason's store, tautic.com. He sells a lot of like little things that if you do DIY and hack-ins and prototyping, he has a lot of things on there that are very, very useful and very, very inexpensive.
Yep. And actually, just recently he has released a angle sensor.
Yeah, it uses a magnet to be able to determine what rotation the board is in versus the magnet.
Yep.
And that is really useful. I think we're going to use it as a encoder for the robo jib.
Cool.
And yeah, we'll see if we can't scam one out of Jason for that. I don't know.
We'll see.
What do you think, Jason? Let us know. Yeah, I think you'd appreciate one of his sensors going into a giant freaking camera robot.
Sure.
Yeah. Okay, well, I think that's it for this week's edition of Toy Maker Television.
Okay.
You guys can watch this show every Wednesday on YouTube.
Yeah.
Don't forget to subscribe. We'll be chatting here in a moment as soon as we wrap up filming in our IRC channel on Afternet, pound TYMKRS.
Yep.
And let's see, this week on Zombie Tech, we're actually going to be talking to Peter the Thinker, who is one of our friends who has actually come here to visit with us at the studio.
Yep.
And we'll be riding out to California with him this spring. So we're going to interview him. He's a engineering student, and he does a lot of cool projects with high voltage and batteries and that kind of thing. I believe they're building a high-speed solar-powered boat.
Yep.
Yeah. And this week on First Spin, we talked about, Eddie was learning about repeat loops and all the different flow control logic that goes into those. So if you want to learn how to program these microcontrollers that we work with all the time, just check out firstspin.tv.
And we made a lot of really bad jokes. So if you like
Yeah,
really
it's
bad
a silly
jokes,
episode. We were obviously
you should listen to that one.
we were obviously a little bit yeah.
It was late.
Okay, we'll see you guys all next week.
Bye.
Bye.
We post videos all the time, so don't forget to subscribe and follow us on Twitter at TYMKRS.